So imagine that you have two functions f and g that are continuous and differentiable. So I have a table of their values. This is x and f prime of x, and this is x and g prime of x. So the question is, what can you tell about extrema of the original functions, like relative maxes and mins? You have to remember that f prime of x is the slope. So at x equals 1, the slope of f of x is positive, and at 2 it's also positive. At 3 it flattens out. At 4 it's a negative, it's going down, and at 5 it's positive. So there are all kinds of things you can tell, but there are also some things that you shouldn't say. For example, I don't know that there's not a relative max or a min between x equals 1 and 2 because I don't know the x and f prime of x values between 1 and 2. So all kinds of things could be happening between these points. Now I do know that x equals 3 is a critical number. I know that. The first derivative is 0, and I know that the original function was continuous. So that is a critical number. If I look, then before 3, the derivative was positive. After 3, the derivative was negative. So I can say that there was at least one max between 2 and 4. Now, if there was only one max between 2 and 4, then it happened at x equals 3. But there could be more maxes and mins because we don't know what's going on in between the values. Now, if you look between 4, which has a negative slope, and 5, which has a positive slope, because the graph is continuous and differentiable, I know that since my slope changed signs from negative to positive, somewhere in here between 4 and 5, there was a min. So I know that there's a min in there somewhere, and I know that there is a max somewhere in here, but I don't know precisely where. Now, if I was told exactly how many critical numbers there were, let's say that there were only 2 total, then I know that 3 is definitely my max, and my min is between 4 and 5. And that would be all I could say. So coming down to the graph of, the table of g prime of x, you can see that I'm starting with a positive slope, then negative, negative, 0, negative. So for all I know, there are 8 maxes, 10 mins, I don't really know. Now this tells me something. The derivative changed from positive to negative between 1 and 2. So somewhere in between x equals 1 and x equals 2, there's a max. I don't know where it is. Now over here at x equals 4, you see that you have a critical number. But I don't know that that critical number is actually a max or a min, because if I look on either side of it, the derivative is negative. So it could have been decreasing, flattened out, then decreasing some more. So that's not very helpful. And again, all kinds of things could be happening between the points, but just, something to consider, and, when you're checking tables is don't over-assume things. Actually, just don't assume things. If it says it's continuous, then you know it's continuous. If it says differentiable, you know it's differentiable, but that's all you know. If it tells you how many maxes and mins the graph actually has, you have a little bit more information, or how many critical numbers rather. But you want to go with just the least amount of information. I know there's at least one max on this graph. I know that there's at least one max and one min on this graph.